let's try 44 from 13.2. In part A, at least, I have show that n cubed minus the quantity of n minus 1 cubed is equal to 3n squared minus 3n plus 1. So, what do you do?
Foil.
Yeah. So, I want to take n cubed and then FOIL out n minus 1 cubed, for which you should probably go to
Whatever.
this thing.
Pyramid. Pascal's triangle.
Pascal's triangle. So, I need to subtract here n minus 1 cubed, right? So that's going to be 1 of what? N cubed. And then 3 of what?
That's just
-3? Oh wait,
So how does Pascal's triangle work?
3 and...
Three.
Oh, 3.
plus 3.
So I need to trade an n, right? So I got an n squared. And then times what? What's the end of that?
Times
Negative 1. And then I have plus 3, and now I trade an n for a negative 1 again. So I got n times negative 1 squared. And then I got a plus 1 of minus 1 cubed. Where'd your n's go? Yeah, you ran out. You traded them all out. Okay, and I'm subtracting all of that junk, right?
Yeah.
So then I've got, alright, so that was a Pascal's step. It's going to be a combine like terms step. Yeah. At least a simplify step. So I got n cubed minus n cubed. That guy?
minus 3n squared.
That's minus 3n squared and you're subtracting it. So that's a plus 3n squared. And then there's a,
Also same thing.
no,
3n
Oh no.
that's a positive 3n that you're subtracting.
minus n.
So that's a minus 3n. And your last term is a
Negative 1.
negative 1 that you're subtracting, so that's a plus 1.
Rock on.
Then you can combine like terms. What are the like terms?
3n squared minus
Well, n
2n.
cubed minus n cubed.
Just the n cubes, right? Otherwise, these guys? No, different powers of n,
That's
right?
quadratic.
So you got 3n squared minus 3n plus 1.
Whoa. That equals.
Wait, I circled that like it was the answer, but what is actually the answer
It's
here?
supposed to be equal.
Equals 3n minus... Yeah, you're beginning.
Yeah, this is really not about that thing you got at the end, it's really about that.
Oh.
This whole thing is the answer because you're showing this. Right, so you started with the left-hand side and you massage it until you get to the right-hand side. Cool with that?
So cool.
Okay, that's part A. Part B. Write this whole mess. Okay.
Yeah.
Okay.
Right the mess.
So, throw my mess up here. Oh, I probably needed that thing. Remember that first thing. I bet I need that.
Okay.
So write n cubed is n minus 1. No, sorry. Write n cubed is n cubed minus n minus 1 cubed plus n minus 1 cubed minus n minus 2 cubed plus n minus 2 cubed. And then dots, and then minus 2 cubed plus 2 cubed minus 1 cubed plus 1 cubed
Okay, I don't have enough room.
minus 0 cubed plus 0 cubed, presumably.
Okay.
Rah.
Well, that's. They're just.
Okay, so why is that even true?
Why?
Okay, well, let me think about this for a second. Write
Because
it down and like.
no, because like,
And they didn't want this last
The
zero
sign.
in there, but it's true anyway.
but look at the
N
signs.
cubed
Like you're just
minus n
subtracting.
minus 3.
Yeah,
It's
like,
they're all zeros. Like,
look at the signs.
Oh, they're all zeros.
they're all zeros. So
This stuff here, right, is adding and subtracting the same quantity, right?
Yeah.
and such as.
Okay,
everything
so
else.
that part's zero. This part in here,
Zero.
also zero. This part here,
Zero.
also zero. This part here,
Zero.
also zero. That part there,
Better be zero.
definitely zero. Okay,
But what about that last minus sign after the last n+2, n-2 squared cubed?
oh yeah, this thing?
Yeah.
So that's gonna be built in pairs, just like this, right?
Okay.
You see
Oh,
that?
right.
That's gonna
Plus-
be, the first thing is gonna be minus an n minus 3 cubed plus an n minus 3 cubed. And then the next one's gonna be n minus 4s, and kind of so on and so forth.
How does
So-
it get to the,
Why does the end go away?
yeah, what, yeah,
What's up?
Why does the
The
end go
end.
away at some point in the
the end?
N? Oh, because n is some finite value, right? If you keep subtracting from it, eventually you'll get to actually 2. Right, if n's 100 or 1,000,000 or whatever, you're still gonna eventually get down to 2.
Any sort of.
See that? Okay, so I'm supposed to show that n cubed is the sum. Ooh, this is tweaky. So they're telling me that I'm supposed to use this to show that n cubed is the sum from j is 1 to n of 3j squared minus 3j plus 1.
What in the world?
What the hell?
Just to show that n cubed
You
equals
guys see
the
that?
sum of 1 to n multiplied by 3j squared minus 3j plus 1.
Okay, but that thing looks familiar,
Yeah,
right?
Super familiar.
Yeah, that's.
Yeah, that's the thing from part A, right?
Yeah.
So this guy from part A was
Was n cubed minus n minus 1 cubed.
J,
Oh, yeah, sorry, j.
right? J cubed minus J minus 1 cubed.
Yeah.
Which is,
Do I have any of those kicking around?
U matters back, you do. Very
Yeah, the very
beginning.
first term there.
Yeah.
well, those,
Yeah, so this one is that for n, right? You see that? So that's 3n squared minus 3n plus 1. And then this next part is 3n minus 1 squared minus 3 times n minus 1 plus 1. Right? If you kind of think about n minus 1 as your variable there,
Oh, I see.
that's a thing cubed minus that thing minus 1 cubed. Right? And so you should be able to write it this way. And then if you continue down in pairs, right, you've got, oops, that was a really shitty bracket, whatever. You've got this one, and then that one. This is that thing for 3, right? You see that? So that's 3, and then, oops, sorry, that's 3 squared. I know, but you didn't take it away today, so.
I took it, someone else must have used it,
So that's this thing. There's a whole box of them in the math lab.
because it was all not
I just keep grabbing one because I forget that they don't work. So that's this quantity for 3, right?
Why is it there?
Because it's 3 cubed and then 3 minus 1 cubed.
3 cubed.
yeah.
And then this guy here,
I'm not understanding. So so you paired negative 2 cubed.
I've paired negative 2 cubed with the thing before it, which
Instead
was
of
3
positive 2
cubed.
cubed? Why did you do that instead of positive?
Because the last thing in this ellipses is 3 cubed.
Okay. But when did the pairing stop becoming like with its own partner?
So, in the blue, right, I was pairing up things and adding them to 0, right?
Yeah.
And then in the red, I'm pairing up a thing cubed
Or the first
and
thing and the second thing.
one thing lower cubed.
Okay.
Right, so they're different pairs.
Which is the
they're
thing.
offset from the blues just by one little bit.
Which equals
You guys see that?
squared minus 3n plus 1.
So this whole thing is offset, and it starts with n minus 1 cubed,
Yeah.
and then it's minus n minus 1 minus 1
This
cubed.
is making sense.
And so then I'm taking that n minus 2, and this one's the minus n minus 3 cubed.
Yeah.
And then there's a whole bunch more pairs, and then right here there's a 3 cubed minus 2 cubed.
Yeah.
And then there's 2 cubed minus 3 cubed, which is the same thing
For 2.
for 2.
And then the same thing.
So that's
See.
3 times 2 squared minus 3 times 2 plus 1. And then this thing is that same thing for 1. So that's 3 times 1 minus 3 times 1 plus 1. It's like the dumbest way to write 1. You guys see that?
Yeah.
So, I think that part B
Does the last one still have a squared on the first term?
is the last one's,
What's
yes.
the three
It
ones?
does still have a squared on the last term.
That's not just one.
It is.
It's just one. It's 1 squared.
1 squared is 1.
Oh, one squared.
So, the answer for part B is
All of that.
all of this.
The ending is C equals 1.
And then part C is use the result the sum from J is 1. Oh, use the arithmetic sequence result.
Here, give me the red, I have green.
Wait, we didn't. We
It's
didn't
okay.
show.
It's okay. Let me be.
I have a green. for
No, I
you.
like the red. It's very vibrant.
Oh, the green is vibrant.
It's gonna be impossible to
Wait, for
erase,
part
but
B,
it's
were we-
really nice right
Were
now.
we supposed to show? Like I still don't see why the.
For part B, this is what I was supposed to show.
Yeah, but where's the summation from 1 to n in that what you've shown?
It's like backwards, sort of.
I see.
Yeah, it feels a little backwards, right?
Mhm.
Because I'm kind of starting over here with the n side and going down. But same thing. Addition doesn't really care about the ordering, right? And so then for part C, they're telling me take this fact that the sum from j is 1 to n of j is 1/2 n times n plus 1. This is that arithmetic sum trick you guys were doing earlier. And show that the sum of j squared is something crazy. So, sum of j squared. J is 1 to n. You guys see a similar trick that I could do?
So show that.
So I'm supposed to show the sum of j squared is n over 6 times n plus 1 times 2n plus 1. Anybody see a similar trick we could try? I don't know, the thing I just did maybe? It's part C of the problem for a reason, right? So, I know this, right? I know that if you sum up j's, you get
1/2.
1/2 times n plus 1.
Yeah.
Right? And here I'm summing up not j's, but j squareds.
Yeah.
You guys with me on
So
that?
you can't just square the whole like 1/2 n plus 1.
Let me think about trying that for a second.
Because if you did, you get 1/4, which isn't really 1/6.
So- the sum of j's squareds, right,
I just don't see that. That's like the,
is like 1 squared plus 2 squared plus 3 squared plus 4 squared up to n squared, right? And if I take the sum up to j, sorry, the sum of j is 1 to n, and square it, that would be like taking 1 plus 2 plus 3 plus up to n, and squaring the whole thing.
Yeah.
This is like a FOIL problem from hell,
Yeah.
right?
Yeah, exactly. So that's wrong.
Okay, so probably that's not what I'm after.
Yeah, probably.
Alright, because I was being a dummy in class today. Here's 13.2, number 44, part C. So from part B, you might remember that n cubed is the sum of 3j squared minus 3j plus 1, where j ranges from 1 to n. Okay, now, if you look at this side, right, for part C I'm supposed to find out what's the sum of j squared from j is 1 to n. Like, that's my goal. So, towards that, I'm going to notice, like, hey, there's a part where you're adding up j squareds in here. And then, related to that, there's an n cubed. Yeah, okay, whatever. There's also a j. I know how to add those up. That's that simple arithmetic trick. And then, if you add 1 up from 1 to n, you get n. So hopefully this will work. I should just be able to rearrange this and solve for that piece, kind of. So the first thing I'm going to do is I'm going to take the answer from part B, right? And I'm going to say that I've got n cubed is 3 times the sum from j is 1 to n of j squared, minus 3 times the sum from j is 1 to n of j, plus the sum from j is 1 to n of 1. And that's really just a regroup my sum step, right? Then the next thing I'm going to do is I'm going to say, okay, so this part with the j squared in it is the piece I'm trying to solve for. This piece is going to be a formula. That piece is pretty obvious. This side I'm just going to leave like it is. So I'm going to rewrite this as n is 3 times the sum from j is 1 to n of j squared. And again, that's the piece I'm solving for, right? So I'm going to kind of mark that chunk. And then this next step, I'm going to have a minus 3, and then what's the sum from j is 1 to n of j's? Like, that's 1 plus 2 plus 3 plus up to n. And there's a formula that says that that should be n times n plus 1 over 2. The thought process on that is 1 plus 2 plus up to, and then we're adding n minus 1, and then we'll add n, and we're just kind of grouping, right? So I'm like, okay, so n and 1 add up to n plus 1, and 2 and n minus 1, those also add up to n plus 1. So I have a whole bunch of stuff that adds up to n plus 1, and there's pairs, right? How many pairs are there? Well, there's n numbers here, and pairs means there's n over 2 of them. So that's the n over 2 part, and then what they add up to. And then this last guy is just plus n. So those steps are, that one's a formula, and this step is a 1 plus 1 plus 1 n times, right? It's just n. And then my goal is to get this blue thing by itself, right? So from there, I'm going to add 3 times n over 2 times n plus 1, right? This guy. I'm just going to add that to the other side. I'm also going to subtract n while I'm at it. So I got n cubed minus n plus 3 times n plus 1 all over 2 is 3 times the sum from j is 1 to n of j squared. Cool. So again, that bit's the bit I'm interested in. Well, without that 3 on it, right? So let's see, looking at the left-hand side, I'm going to put in a common bottom over there. So that's going to be 2 times n cubed over 2 minus 2 times n over 2. So now I've got a common bottom of 2 all over there. So I'm going to combine that. So common bottom gives me 2n cubed minus 2n plus, and then I'm going to FOIL that one out, or distribute at least. It's not really a full-on FOIL. So if I distribute that, I got 3n squared plus 3n. And then all this jazz is over 2. And this is supposed to be, oops, forgot the 3. 3 times the sum from j is 1 to n of j squared. Okay? So then I'm going to combine like terms on this left-hand side. So I got a 2n cubed, a 3n squared, and then there's a plus n over there, and all this is over 2. And this is supposed to equal 3 times the sum from j is 1 to n of j squared. So then I'm going to multiply through by a third and factor. So I'm going to factor up here. So all that right now just in common has an n in it, right? So I'm going to pull an n, and we're going to be over 2 times 3 is over 6. And then there's left a 2n squared plus 3n plus 1. And this is going to equal my sum from j is 1 to n of j squared, right? And then I'm going to come back over to where I started, because now I know what I'm solving for, right? And I'm going to factor some more, right? So I got my sum of j squareds, right? And I got an n, and then we're all over 6. And then I need, well, some kind of a factor method that works on 2n squared plus 3n plus 1. So really kind of off on the margin. Thinking, alright, 2n squared plus 3n plus 1. I'm looking for 2 numbers, right? They multiply to 2 and add to 3. So those are 2 and 1. So you might rewrite this as 2n squared plus 2n plus n plus 1. And then factor by grouping. So out of the front 2 you can pull a 2n, left with an n plus 1. And out of those guys you can get a 1, you're left with an n plus 1. So you pull these guys out. So all told here on the top, I have a 2n plus 1 times an n plus 1. And thus, I went and found this thing. Right? So this is the formula the book got. Cool, victory is mine. And I don't know why I was having a problem today. Sometimes I'm an idiot, sorry.